So our goal is to answer the tutorial sheet. Okay, so I'll start with question 1. Don't worry if you're new, I'll explain the concept as well, you've never learned it before. So learn using the questions. So here we are told the universal set is having numbers from 1 to 10, and then we have sets A containing members, as we can see, B, C. Now the questions are, we are supposed to find these sets. Okay, so the first one, we have to find A intersection B complement and then complement, and then here we're supposed to find A complement union B and then the complement of it, and then we have that and that. So we are going to answer all these. So if I look at the first one, we are taught to find A intersection B complement and then complement of it. So certain things that you need to know is, every time you're given brackets, please ensure that you start with what is in the brackets before you handle what's outside. So in the brackets, we can see that we have A intersection B complement. Let's try to find A intersection B complement. Okay, A intersection B complement, we're trying to find the intersection between set A and B complement. Now you know that in the question, A has already been given. If we've been given B complement, we've not been given B complement. So it's a good idea to find it before you proceed. Okay, so let's try to find B complement. So B complement means the elements that are outside B but within the universal set. So if you check B, where is B? B is having 2, 4, 6 and 8. So the other elements that are in the universal set but are not in B are the complements of B. Okay, so the definition of a complement is elements outside that given set but are within the universal. So in the universal, if we move 2, 4, 6 and 8, which are contained in B, the remaining elements will give us B complement. So we have 1, 3, 5, 7, 9 and 10 as the only remaining elements in that set. I know sets are very simple and some of you may take them for granted, but you see, pay attention to everything I'm saying. Okay, these are the same simpler things that are going to be in your assessments, and you begin struggling with them, so please pay attention. So what B complement is. So now that we have our A and our B complement, we can now try to find their intersection. So our A is there, and then this is our B complement. So our goal is to find the intersection. Remember, what we're trying to do is we're trying to first of all simplify whatever is in the brackets. We've seen that in the brackets we have A intersection B complement. Alright, let's move. So our A is there, and then our B complement is what we're able to see here. So let's try to identify the common elements between the two sets. I can see 1 is common, I can see 3 is common, I can see 10 is common. Is there anything else that I've omitted out that's common between A and B complement? Have I omitted anything? Okay, so we found A intersection B complement. Now, in the question, let's bring back the brackets. So they want us to find the complement of what we have. Now, notice that we've already found what is in the brackets, which is 1, 3, and 10. So now it's like we're trying to find the complement of it. So the complement of any set implies remove the given elements, and then what remains in the universal set is your solution. So if we remove 1, 3, and 10, what remains? 2, 4, 5, 6, 7, 8, and 9. So what gives us the set they wanted us to find? Okay, simple and straightforward. Is there any question before I show you the alternative way you can use to answer this very question? Okay, so the alternative way is by distributing the complement that is outside. So we have A and B complement. So A will become A complement. The intersection becomes a union as you distribute this complement that's there. And then B complement will become just B. So if you can try to simplify this at your own free time, you'll notice that it will give you the same result there. Okay? So yes, I can hear there's a question somewhere. Please be loud, we are not getting you. Okay, so I don't know if you've seen, that's what I've already shown you here. I've also shown you that you can distribute the complement applying the Morgan's law, which I have. So it's still okay going by that way. So we move to the second question, which says A complement union B complement. So for this one, let's go by the De Morgan's law. So De Morgan's laws, you are told that if you're going to have A intersection B complement, the idea is A becomes A complement, your intersection becomes a union, and then B becomes B complement. So in other terms, you are distributing this complement to everything that is inside there. So you can do the same to what we have on top. So A complement will just become A. The union becomes the intersection. B will become B complement. Now, some of you who've gone beyond, who've been watching the videos I've been sharing to the group, understand that A intersection B complement is the same as what? No one is able to remember? Okay, so it means A minus B. In other terms, A without B. So I feel that is the fastest way of simplifying it. Okay? But anyway, for now, let's use the same move. So now that we've simplified, we have A intersection B complement. So we already have our A. Let's first of all try to find our B complement, which we did already in the previous question. So we moved 2, 4, 6, and 8 from the universal. What remained was 1, 3, 5, 7, 9, and 10. So what is B complement? Now we're trying to find the intersection between A. So I can write my A. In A we have 1, 3, 6, 8, and 10. And then we're trying to intersect this with B complement, which is adding 1, 3, 5, 7, 9, and 10. So what are the common elements between the two sets? I can see 1 and 3 are common. I can see 10 is also common. So we have 1, 3, and 10. Now, what if I went by the other method where I'm saying A intersection B complement is the same as A minus B? Now, A minus B, I said it means A without B. So if you look at A, look at your A. Remove the B elements. What are the B elements? 6 is a B element, 8 is a B element. What remains? 1, 3, and 10. Have you seen that this is the fastest way actually than simplifying? Okay, so is there anything, any question? Are we getting something? Are we getting there? Okay, so don't be deceived. These things are very simple and straightforward. Just be focused. Just sit down, solve something simple. All right. So don't stress yourselves unnecessarily. Let's proceed to the third one. Let's look at the third one. We see the way it's going to come out. So for the third one, we have A intersection B union C. So I said start with what is in the brackets. So A intersection B. So we have both A and B in the question. So let's just identify the intersection. Let's identify the intersection. What are the common elements we have here? I can see 8 is common. I can see 6 is common. So 6 and 8 are common, right? So 6 and 8 represent the A intersection B. I don't know if I've missed anything. Try to check it. Okay, then for C, let's bring back our C. Our C, we've been given 1, 4, 6, and 10. So we're trying to find the union. The union, you've been dealing with the union from primary school. So union implies you combine the two sets. So let's combine them. So 1, 4, 6. I think only 8 will be added to the other part. So 8 and 10. So if you've got a common element, in this case 6, you only write it once. So we are done with the third one. Are we good? I want to get the complicated part. These things are very simple. So if you've understood, you can give me a sign you have. Okay, so I'm giving you exactly 30 seconds to answer the fourth one, and then you can unmute yourself when you have an answer so that we hear your resolution. So your time starts now. When you're done, just unmute yourself. I'm listening. So I hope you got that. You only have 30 seconds and your time is ticking right now. Okay? So if you're watching this as a recorded class, feel free as well to take part before you check the solution. Anyone who is done already? Okay, so if you've just joined, we are answering this question. If you don't know how to go about it, just wait just a few more seconds. Would have moved on. Yes, please go on. If you found the answer, tell us the answer.
Can I say how to go about it?
I don't want the answer. Give us the answer.
Okay.
So if you've got an answer, unmute yourself and tell us the answer.
The answer is 1, 4, 6, and 10.
1, 4, 6, and 10. Okay, anybody who can confirm this answer? No one is confirming the answer. Okay, you guys that don't want to talk, I don't know, maybe it's your first time. We'll see next time. Let me go on and answer it. So A union B, it implies you combine A with B. Now, if you combine A with B, what are the common elements with C? So if you look at A union B, let's go direct. In the question, we've already been given A and B. So the union of the two sets implies we combine them. So let's combine A with B. we are going to have 1, 2, 3, 4, 6, 8, and 10. These are the elements that are gotten after combining A with B. Now we have to find an intersection with C. C is having 1, 4, 6, and 10. Now let's try to identify the common elements. I can see 1 is common. I can see 4 is common. I can say 6 is common. So is 10. So all the elements of C are part of this set. So therefore the intersection remains C itself. Simple and straightforward. Anyone who has not understood what I've done there, please feel very free to let me know if you've not understood. And if you have, let me know as well. You guys don't want to talk anyway. I'll proceed. I'll assume you have gotten. So question 1 we are done just like that. We are on question 2 now. Question 2. Part 1, we are supposed to express these ones in simplest form. Are we ready to handle this question? Are we ready? So I've given you permission to unmute yourself if you want to say something, but you still don't want to talk. So
I'm unable to get you. I think you've muted your microphone. I'm also unable.
okay, so I don't know, I didn't see that anyway. Thank you for that. Okay, so I hope you got the explanation here.
I wasn't able, by that time your microphone was muted, so
Okay.
I didn't get anything.
Alright, so what we said here is we said we're trying to look at A union B intersections. Yeah. So if you look at A union B, in the question we've already been given A and B, right? So combine the two. When you combine them, these are the elements you're going to have. Now you're supposed to find the intersection with set C. C has already been given as well. So what are the common elements between these two sets? You see that 1, 4, 6, and 10 are common. It's a very simple question, right? Have you gotten that?
Oh, yes, I have. Thank you.
Okay, so now are we ready for question 2 and 3? Where we are supposed to simplify.
Yes.
Okay, so let me ask you a few things to verify if you're ready. A minus B is the same as what?
A minus B same as A intersection B complement.
What if I told you A minus B complement outside? So what would imply in the bracket is going to be A intersection B complement, and then there's a complement outside, so A becomes what?
Complement.
And then intersection,
Union.
and then the B complement becomes what?
B complement is same as B.
Okay, so if you've gotten this, then we are ready to go. So let's move. Let's distribute the complement that is outside to what is inside. So the P complement will become P. The union will become intersection. Q minus R will become Q intersection R complement. Now this complement is distributing to everything inside, so it will also apply to the bracket. I don't know if you've gotten that anyway. So we can move. We have P intersection. We can still distribute this complement whatever is inside. Q becomes Q complement. Intersection becomes union, and then your R becomes R complement. Okay. Oh no, the R complement is supposed to disappear, right? Yeah, yeah. Can we simplify this beyond this point? Okay, so that is going to be a distributive law which will make it to be more expanded again. I think the simplest form is this same form. Otherwise, we're going to have P intersection Q complement union P intersection, which I don't think is a more simplified form. So we can end here for this question. Have we seen what we've done to simplify it from a complicated form to a simpler form? So the reason why we're looking at this is there are going to be questions where you looked at question 1, right? Now let's say they gave you such a complicated expression and then they ask you to find the set. So it is advisable to simplify it before you can actually get to find it. So you're not only learning these to simplify but also to apply them when you're answering questions given in complicated forms. And then we can look at 2 now. X union Y intersection X. So I don't know where this is going to take us, but there's what we call a distributive law. I've explained all these concepts in simpler terms in the videos. If you are new, don't worry, I'll still share. So distributive law, please mute your mic if not until you're asking a question. Alright, so distributive law, we take it as multiplication. You know, this kind of, if you've got a 2 outside and then you have like 3 plus 6, this is the same as 2 times 3 and then plus 2 times 6. That's distribution. Okay, so let's apply the same concept. We'll take union to be a multiplication, so it will be X union Y. Look at the positive, it has become the middle part, so intersection will be the middle part, and then again we'll multiply X union X. What we have X union Y intersection. Now combining a set with itself is just a set itself. Now the question you have at hand is, what is common between X combined with Y and X itself? What's common between the two? You combine X with Y and then you compare it with X. What's common between the two? The union of X with Y and X. What's common?
X is common.
Okay, so X is common. That's the answer. Now let me try to see what you're thinking. Let me try to assess you. And it's okay if you get it wrong. What would you say if we had X intersection Y? What would be the answer in such a case if we didn't have intersection, if we didn't have union but we had intersection? What would be the answer there? Yes? Okay, so somebody says the answer is x intersection y. Pardon? So are we in agreement what you said?
Sir, the answer will also be x intersection y.
Okay, so this is good. No, it's good. That's the answer. So if you've not gotten it, it's fine. You understand later. But if you don't get it, try to come and draw the Venn diagram. Let's call this one our x, let's call that one our y. Let's identify the region called x intersection y. This is the region of intersection. Now, what is common between x and x intersection y? That's what the question is asking. What is common between x intersection y and x? What is common between the two? Or what is contained in both between x and x intersection y? So you notice that x intersection y is actually part of what? X intersection y is part of what? It's part of x. So it's common. It's contained in itself, and then it's also contained in x. So this is the answer. Don't worry, it's okay. It's okay if you don't get it for now.
I have a question.
Yes.
So, the answer you found that x intersect bracket x intersect y. That was the answer.
No, sir. No, the answer was x to our question at hand.
X only.
Yes, for this question.
I'm a little bit behind. So
Oh.
we eliminate the y.
X union y intersection x. Focus. Don't be distracted. So x union y, we said take this as multiplication, becomes x union y. This intersection will come on the middle, and then again we'll multiply. I'm using multiplication to help you understand. So whatever is outside is like distributed to what is inside. X union y, and then x union x. That intersection comes on the middle. So we say the union of x with itself is just x. So we have x intersection x union y. So the question was, what is common between x combined with y and x? What's common between the two sets?
X.
So what is how x is the answer? Are we together? Alright, if we look at number 3, we have m intersection n union m intersection n complement. Now this is like distribution in its like complex form. It's like it's already expanded. Now all you have to do here is now apply factorization. Check what is common. What's common? M intersection is common in both brackets, right? So we'll factorize it. I'm using the word factorize to help you understand easier. So I can write M intersection. Now in the first bracket, what is remaining? N is remaining. And then so we'll write the union. In the other bracket, what's remaining? Okay. Now I want you to understand one thing. That being the inverse set, if you are going to have a set called n complement implies the region that is outside what? N complement implies the region that is outside n. That is n complement. And then n implies what is inside. So if you combine the two, what do you get?
You get the universal.
You get the universal set. So here you're going to have m intersection the universal set. M intersection the universal set gives you what? If you combine the universal set with any set, you know that any set is contained in the universal already. So any set intersected with a universal gives you what?
The universal itself.
It will give you that same set. You can't say the universal set is contained in M because you're looking for the common set. What's common? M is contained in the universal. The universal is not contained in M because M is contained in the universal set. Okay. So with whatever I've given you for 1, 2, and 3, I want you to apply that to 4, 5, and 6. Okay? And then I want to see the solutions in the group after this. Then for 3, let me guide you on how I want you to go about it. So we are told A and B are disjoint subsets. So disjoint subsets are sets that don't have an intersection. So come up with this kind of a Venn diagram with A and B. Now, is there a way you can simplify this? So you can also just try them out. I don't want to give you a lot of data already. Some of you have not learned anything in class yet. Okay? But with what you've learned tonight, I think it's enough, and at least you've got something to build on. Okay? I'll share some few lessons that I expect you to watch before the next class. And all these questions are going to be answered, and I'll upload them to our learning platform. Actually, you have access to it before. By Monday, all the solutions will be ready in video form. Yeah. And in fact, all these questions have already been answered. There are a lot of other tutorials that are already there and lessons. Yeah. So tomorrow we'll continue, I believe, should be chemistry or physics. Yeah. So make sure you join. Invite your friends to come and join the next class. And just in case you want to check out other lessons, I'll share the link in the description. So these classes will be ongoing over the weekends, Friday, Saturday, and Sunday. And then within the week, you'll be watching the videos on the site to help you understand at your own convenient time. And if you've got questions, you can always share your questions. So is there any question before I go?
So where can we find the link for joining your classes?
Okay, so I don't know where did you join from?
I joined from my tutorial group. That's where I found it.
Okay, so before you leave, don't leave the meeting yet. I will share the link just here. In case you're not in the group yet, you can join. Okay? And then let me show you mathematics, for example. So math on our learning platform online, if you are going to open the course, you'll find that all the topics that you're going to learn are already there according to the topics. Yeah. My network is a bit slow at the moment. So set theory. So I've explained all the basics in like 30 minutes. You learn about the subsets, the difference of sets, the Morgan's laws. All the concepts I've been using to answer the questions are all explained. Okay, simplified. There are questions. You notice that all these questions actually of simplifying are already there on the site. And then the other advanced questions that you can also look at. There are concepts on shading, describing the shaded region, presenting sets on a Venn diagram, set builder notation, and many other concepts, irrational numbers. So everything you need to learn is already available. You can see even as far as calculus, all the topics are already available. Okay, but I advise you not to rush. Just take your time. Yeah, so you can in case you're interested, you can register for all these. Yeah.
Sir, I was just asking for your line. Do you assist me with your number?
No, So for those ones who want to text, you can get the number. So the number is you can just text on WhatsApp. The number is 097 95 800 34. So that's a number you can text for registration, and then for any queries you have, if you want to be added to the group, you can text that number as well. If you want, you can wait for the link right now. I'm going to share the link before you leave.